In this video, we will demonstrate how a problem related to the number of symptoms treated by a doctor in a day may be modeled as a probability generating function for a compound distribution. The context for this problem is the Community Health Center of Lubbock, Texas, a nonprofit medical services provider for the underserved populations in Lubbock, Crosby, Lynn, and Garza counties.
This is one of our clinics here in Lubbock, Texas. It's our Arnett Benson Clinic. We do medical and dental services out here, both for children and adults. This area is considered a medically underserved community, as well as some of the surrounding counties. We serve all the individuals from the surrounding counties and just provide the best care that we can. One of our main clinics we have several departments in that clinic. We have an eye clinic there, we have a obesity grant clinic there, we have a mental health clinic, adult women's health services, and also that houses one of our dental clinics. We do have a centralized call center where any patient needing to set a both medical, dental appointment, call into that call center. From there, the calls are rerouted to our clinics and patients are scheduled. Some of our off-site clinics do schedule their own appointments just because it's easier. The volume of calls coming into the call center is high, so that's why sometimes some of the calls are rerouted to the clinics themselves so they can schedule their own appointments. Probably one of the biggest challenges always seems to be maybe the lack of services, especially in rural communities where you don't have the resources that a bigger metropolitan area would have. Also having just educating our patient population in regards to their health. Sometimes some of the basic healthcare needs that some of our patients present with, they could be very easily addressed with appropriate, culturally sensitive health education. So we not only serve to help them meet their healthcare needs, but also in a way serve as educators to help them understand why they are experiencing the healthcare issues that they do. The clinic's been around for a couple of years, I would say about 20 years. There was a transformation in 1995 where it became Community Health Center of Lubbock, and since then we've been adding some of the clinics that we currently have. In 1995 we started off with four clinics. Since then we've added the 3 other clinics plus the mobile units to total the 8 clinics that we currently now have.
The time spent by doctors diagnosing symptoms varies on a day-to-day basis depending on the number of patients seen and the number of symptoms each patient has. In order to schedule a doctor's time most efficiently, the Community Health Center of Lubbock would like to know more about how many symptoms a doctor diagnoses on an hourly basis. Though the problem presented in this video is representative of one in that industry, keep in mind that all data given in this video is fictitious and for illustrative purposes only. Let Xi equal number of symptoms the ith patient has. Xi is distributed as a Poisson. In addition, N equals number of patients seen by a doctor in an hour. N is also Poisson distributed. So both the number of patients and the number of symptoms a patient has are random variables and distributed according to a Poisson distribution. The desired information or problem has 3 parts. What are the expected number of symptoms diagnosed in an hour? What is the probability the doctor will diagnose less than 5 symptoms in an hour? What is the probability the doctor will diagnose more than 10 symptoms in an hour? The problem of obtaining probabilities for the number of symptoms diagnosed by the doctor may be solved by finding a probability generating function of a compound distribution. In particular, let S equal number of symptoms diagnosed in an hour by a doctor. Finding the probability distribution of S directly would be difficult, but finding the probability generating function for S is rather straightforward. In particular, use the following. From the study of probability generating functions, use the following equation. So to solve this problem, One would need to substitute the appropriately parameterized generating functions for a Poisson distribution into this equation, then extract the expectation and probabilities of S using the following equations.